Wait for 2 minutes. और कौन आने वाला है? Classroom. Okay. Before we start, what about the assignment completion? Sub all done from all of you? क्या challenges आ रहे हैं? What are the problems? Sorry, repeat.
Your data type है ना, जो अपना present
House price. हाँ.
उसमें जो data type है मैंने convert नहीं किया था.
कौन सा data type?
जो object है ना,
हाँ.
वो numerical में नहीं है.
Okay. सिर्फ वही एक प्रॉब्लम है. Okay. Apart from that, what about you, Komal?
I couldn't complete it.
Both linear and logistic.
The logistic.
Okay.
Not errors, but I couldn't get time to do. I have written half.
Mm-hmm.
It's done. Data pre-processing is done. Statement has been done. The second part is done.
Second part as in the evaluation.
Evaluation.
Action. Both complete?
So only one is complete.
Are you not getting time or क्या है?
Yesterday I did not get time of the sessions.
Okay.
I was out.
So are you okay if I continue with the next one? Because
Yes, sir. We covered that.
we have to cover a lot of things. थोड़ा fast भी होना है अभी.
Sir, we have got the answer. Just
See, concept is fine. You understand the theory, that is fine, but also the hands-on part is equally important. Because once you understand this, any algorithm that you implement afterwards, it follows the same logic. So if you don't understand this thing, then even here you'll have the same issue. Okay? Now what to do? So that should not happen. Okay, who's online? Manish and Kamlesh. Good morning. Acha, sorry, Kamlesh.
Good morning, sir.
Kamlesh, are you going to be offline or online?
I will be online. Yesterday I have dropped the message that I am on the site, so.
Okay. Okay, fine. So today we are going to start with our new topic, which is decision tree. So decision tree is a very, very simple algorithm, which is part of our machine learning, which is mainly used for doing binary classification or multi-class classification. Okay, so it is meant for classification and it can also be used to do regression, but it is primarily meant as a classification algorithm. And decision tree works based on something called as a technique called greedy algorithm. Any computer science students here? क्या है greedy algorithm? Research karna. Okay, I'll just tell you what is greedy algorithm. Greedy algorithm means you make a decision. Okay, now whether the decision is right or not, You do not know. Okay, it may work in your favor, it may not work in your favor. Okay, so once a decision is made, you don't revert. Nahi yaar, galat ho gaya, I'll go back and correct me. Okay, so that is called greedy algorithm. One decision made, you stick to that, and based on that result, you make the other decisions. Okay, so it works on that principle of greedy algo. So here it also follows something called as a divide and rule. So what it does is, you have a data set. It splits the data into two, yes and no. Then based on the result of yes, it will again split the data into two, yes and no. I'll explain it with an example. And then this yes is again split into two, yes and no. And then this no is again split into two, yes and no. And it goes, and finally it reaches the end. And then it will decide. Okay, so based on this split, what is the class? It could be a positive class. Based on this split, this is a negative class. Okay, now come to the right-hand side. So this is a left-hand side. Now what is the right-hand side? When it is no, then again it is going to split. When it is yes, again split, no, again split. So keep splitting and then come to the last. So based on this result, it will be negative. Based on this result, this is positive. Okay, a series of decisions that are made at every stage. That is called as a decision tree. Okay, so it's a very, very simple algorithm, and it works best when your data is non-linear. Non-linear का मतलब क्या है? When I say my data is non-linear, what is the meaning of it? Huh?
It is not evenly distributed.
It is what?
It is not uniformly distributed.
Non-linear. Non-equal value. Values are never equal. Non-linear means categorical data, basic data. Okay, for example, type 1, type 2, type 3. Okay, male, female. Greater than, let's say 25, less than 25. So these are categories. So when you have these kind of data, decision tree works very well. Okay, it's not that decision tree does not work with numbers. So you have different types of decision tree. So based on the data, decision tree works on that particular algorithm. Okay, so there are three main types. I'll explain that. Okay, so this is the basic functionality of a decision tree. So you have a data which is split using the divide rule or the greedy algorithm, which is how it is. So how exactly does the tree split? So let's look at. So you have something called as a root node. Root node is the top. So if I have 5 features in my data will be split. Okay. So that first column on which my data is split. Let's say that I have a data set like this. Let's say employee attrition. Okay. Now attrition can have 5 values. Let's say gender, education, experience, or can have distance from home, and let's say current salary, for example. Okay, so these are my features, and my y variable is attrition, which is 1 means you have left the company, organization, 0 means you are still an employee. Okay, binary classification. Now, what are the factors that influence attrition? So we have already seen this in logistic regression, right? Now, how does decision tree work? So using the split. Now, out of these 5 features, the tree splits on one feature initially, the first split, that is called as the root node. Okay, now let us assume that gender is the node. So here I'll have gender. So what are the values for gender? Male, female. So when I said yes, no, it is not literally yes and no. Okay, it means true and false. So here gender is male and female. Let's take only 2 for the time being. So when the gender is male, so this is over. Now what is the next split? It can be anything. Okay, I'll tell you the condition. Okay, there's a specific condition. Using that, it will find out which is the most significant feature to split on. Okay. So once gender is done, now out of these 4, let us say, let's say experience is the next best feature. Okay. So when male, then experience. Okay. So female also will have experience. So let us say that based on some calculation, the most optimum value for experience is greater than 10, less than equals 10. Because it can split into 2 parts only. What about the female experience here? Less than equals 10, greater than 10. Okay. Now I can either stop here or I can split till the end of the features, or I can stop midway. Okay, now experience is done. Now what is the next one? So let us assume salary is the next significant one. So here salary. Okay, now salary, let's say less than 8 lakhs, greater than equals 8 lakhs. Okay, so here it is going to be again same condition, less than 8, greater than equals 8. Okay, here less than 8, greater than equals 8, and less than 8, greater than equals 8. Okay, so now this is done. So let's take 3 features. So this is the root node. Okay, this is the split. This is the inner node. Inner node means what are the next features inside. And finally, I have something called as the leaf node. This is called as the leaf node. Leaf node means the decision. So how do you read this? When the gender is male, let me take a different color. When the gender is male and the experience is greater than 10 years and the salary is less than 8 lakhs, what is the decision that you want to make? Let's say attrition. Okay. So it is an AND condition. When gender is male and experience is greater than whatever number and salary is this, the person or the employee will leave the organization. So this arrow bar that you see, this is called as the path. So it is like a formula. So when I say P1 means gender male, experience greater than 10, salary less than 8. So whenever I have a record matching this condition, what is going to be the prediction? The prediction will be this leaf node, which is attrition. Now go back. When gender is male and the experience is 15 and the salary is greater than or equals 8, let's say it is no attrition. So if a record comes where the gender is male, experience is 4 years and salary is 15 lakhs, what is going to be the prediction? It will fit into path number 2. So this will predict as no attrition. Clear? So now left side is over. Now come to the right side. When gender is female, let's take a different color. So when gender is female, so same logic. When the experience is less than 10 and the salary is less than 8, let's assume that the leaf node is attrition. Okay. And when the experience is less than 10, gender is female, salary is greater than 8, let's assume that there is no attrition. And similarly, I have for this, I have no attrition, and for this, I have attrition. So now I have the entire tree structure. Now a new record comes where I need to make a decision or I need to make a prediction. So the records are gender is female, experience is 20 years, salary is, let's say, 30 lakhs. So where will this fit?
No attrition.
This is gender, this is experience, and this is salary. So it will be in the right side of the node. That is the first condition. Experience is 20. That means it is greater than 10. Then salary is 30. So that means it is going to be here. So here it will be attrition. Now, can you tell me, is there a formula here? Are we building a formula like linear regression and logistic regression? Is there a formula?
You're comparing it.
Each time we are only doing a comparison. There is no formula as such. Isn't it? Where we have the beta values and simply using the formula and plugging it into our data. We are not doing that. Isn't it? So whenever you have these kind of algorithms, these are known as non-parametric machine learning models. It's a very commonly asked question. What is the difference between a parametric machine learning model and a non-parametric machine learning model? So parametric machine learning model is where a formula is built. Linear regression, logistic regression are parametric. You have a formula, y equals A plus BX. Whereas here there is no formula. When you give a data, the decision tree gets created based on the input. Okay. So just remember this term, non-parametric machine learning model. Okay. Now, when I am splitting the data, let us say that I have 100 records and my first split is based on gender. So this is F and this is M, female and male. Now, approximately, what is going to be the ratio of female versus male? So let's say there are 45 female employees and 55 men. Okay, so 45 on one side, 55 on one side. Now I am splitting this based on experience. Okay, so this is going to be, let's say, less than 10. This is going to be greater than equals 10. Now, what will be the ratio? Approximately. So let's say less than 10, there are 30 people. So greater than equals 10 will be how much? 15, because it has to add up to 45. So this will be 15. Similarly for male, experience. Less than 10, greater than equals 10. So let's say less than 10 is 39. So this will be 16. Okay, so this circle that I have put, that is the record count. Okay, so 45 plus 55, 100, that is the total count. 45 when it is split, 30 and 15, 39 and 60. Now, can I split this further to make a decision? I can. Now, till when you will do a split?
One of the leaf nodes become 0.
Not leaf nodes. You will keep splitting till you will get a 0 in the decision. That is all negative or all positives. Okay. Now, for example, after experience, I'm splitting this based on what was that? Salary. Okay. Now, if I say salary less than 10 lakhs, salary greater than equals 10 lakhs. Now here, if I get 10 lakhs as 30 and greater than equals to 10 as 0. Let's say I'm getting a situation like this. Now, can I split greater than equals 10 further? Doesn't make sense because there is nothing to split. So this kind of a situation where I cannot split further is called as a pure state. A pure state of a decision tree means no further splits. Okay, it is called pure state, or you can also call this as a pure subset. Both are same. So is it always easy to get a pure state? Not every data will have a pure state with limited features. Okay, you may have a majority, but you may not have a pure state. For example, if I have the gender male experience as 10, and if I have the salary, so if I give less than 10 and greater than equals 10, so this 39 may split like this, 33 and 6. So the count will vary depending upon your data. Now, can you tell me, based on what you have learned about decision tree, what is the advantage or what are the advantages?
Proper finalization.
Yes, you can actually track how a decision is made. You just need to follow the path. Okay, gender is this, experience is this, salary is this. So it is making a decision. So you can actually plot a decision tree in Python also. You can track. Okay, so it is easy to read and easy to interpret because it is nothing but a set of if and else condition. Okay, so that way it is easy to read and interpret. What is the disadvantage? What do you think?
Feature selection.
Okay. Feature selection.
Like how significant.
Okay. So one good thing about decision tree is when you build a model, it actually gives you a feature selection for all the features. Okay, you don't have to write any special code. Okay, you can directly get it from, there is a method called important features. Okay, you can actually get a score. Okay.
So, like we need a logistic, we used to select the features based on the p-value.
Correct. So here you can directly using the summary, isn't it? So here you have a inbuilt method called important features, so which will give you a score. So bigger the score, better is the, or more significant is the feature. So feature selection will come later on. But before the feature selection, what disadvantage do you see?
We cannot reach the pure state everything.
Okay. So we have the majority in that case. Yeah, getting to the answer. I'll give you a clue. You are working with 25 features. Now tell me.
The tree becomes very lengthy.
Correct. When you have 25 features, or let's say you have a lot of features, what will happen to the tree? Tree will grow like this. Okay, it will become too big. And when you have to make so many decisions, it is like you're going for a movie and you're asking 25 friends, so each person will say something. So end of the day, you will sit at home. Okay, so you won't be able to make a proper decision. So same thing here. If you have too many features, the model will definitely overfit. It will give you a very poor result. So lesser the features, better will be the performance in a decision tree. So you can say disadvantages, too many features, will cause overfitting due to, we can say, overgrown trees. Clear? So how do you fix this problem when you have too many features and I want to use decision tree? So how do you ensure that my model does not overfit? Yes, so you have to first select the significant features. That is one. Number two, there is something called as pruning a decision tree. Anyone who likes gardening here? घर पे garden है? Or what do you do when your plant becomes too big? Same thing here also. When the tree becomes big, you are cutting off unwanted portions, but the plant still remains intact. So what are you chopping off? Dead leaves or unwanted branches. Okay? Now decision tree also has unwanted elements. Elements means unwanted features. Now why do I want to split based on something which I don't require? So chop that off. You will still get the decision. So that is called pruning in decision tree. So pruning will actually reduce overfitting. So this is, you can say, chopping off unwanted features. Or you can say splits. Then the third step that you can use to get a better result using decision tree is called hyperparameter tuning. You must have heard this name, isn't it? Hyperparameter tuning. Was this covered in the previous hyperparameter? Linear regression, logistic regression? Right? Okay. So this is a very, very commonly used technique in machine learning called hyperparameter tuning. Now, what happens when you're using an algorithm? Most of the time, we take the default parameters. Right? Let the algorithm decide using the default parameters. But not every time the default parameters give you the best result. A very simple example. Train test split क्या करता है? 70-30 नहीं करता. Split करता है. Right? Now, 70-30, who decides? We decide. Is it always 70-30 that I split? Can I split 90-10?
Yes.
So this is called hyperparameter tuning. I am giving my own values to split, overriding the default values. So if I give 10% as the testing split, so 90% will go to the training. Okay, so wherever I want to specify my own values by overriding the default values, that is called parameter tuning or hyperparameter tuning. तो उसका hyperparameter क्यों नाम है? Because these parameters are related to the algorithm. So in decision tree, I can do hyperparameter tuning. Now, what are the parameters that you can control? Number one. Now, if you go back to this diagram, so here, how many features are there in this tree? 3 features. Now, imagine if I had 10 features. Okay. So what would be the size of the tree in terms of its height? Greater than this? Yes. Right? It would have been like this. Right now it is so much. So the first parameter that you can tune is controlling the height of the tree. Okay? So controlling the height means if I say I want only 3 splits. Okay, now do not confuse the height with the number of features. I can still have 25 features, but height of 3. Okay, if I have 25 features, it will split on the 3 significant features and stop. Because I've given the restricting the height to 3, but I'm not taking 3 features. So one is you can control the height. Number 2, I can control the features. That is out of 25, how many significant features you want. And then, of course, you can have a combination of height and features. समझ में आ रहा है? So if I restrict my features to 6 and I don't give a height, it will split on all the 6 features. Okay, so height and features will be same. But if I have number of features as, let's say, 30, and if I restrict the height to, let's say, 4, it will split on 4. But feature list will be the same. Now there is another feature called as CP. Yes, CP, I'm not getting into too much of detail. It's quite a complex topic here. So I want to first cover the basic decision tree, and this hands-on will be a slightly tricky thing. So I'll do it later on, okay, maybe next week. but I'll explain the theory part. CP stands for complexity parameter. Now, what CP means is, in a very simple way, I can say, what is the quality of the split? It signifies quality of a split. Now, let us say that I have 5 features. Okay, I have 5 features. And my Y variable is a binary classification. It's a binary classified, positive and negative. Now I'm taking my first feature on which I have to split, which is, let's say x1 is the feature. Now ये split हो रहा है in yes and no. Now in the first split or after the first split, can I tell whether my Y variable will be positive or negative after the first split? It is very difficult. Okay, the chances of errors are very high in this case. Now I come to the second split. So let's say x2. Now based on x1 plus x2, can I say what is my Y variable? Better than previous one. Now if I take x3, now if I combine x1, x2, x3, can I get a better, can I make a better decision? Yes. So that means your quality of split is improving with each split. And that is called complexity parameter. So what you are saying here is, my initial split, the complexity parameter is very high. So here it is very high. And as the splits are increasing, my complexity parameter is reducing. जितना split बढ़ेगा उतना complexity parameter कम होगा. So there will be one stage in the split where the complexity parameter will be the least. So there are chances that it is splitting 10 times. Okay. So high, low, 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 low. Then in the next split, it can again be high because that's an unwanted split. Okay. That can also happen. So I am splitting till a point where the complexity parameter is the least. So I can tune that parameter also. Wahan tak split, ignore the rest. So basically you are pruning that portion of the tree. Okay, that is called complexity parameter. So usually this number is a very small number. Like 0.00, 0.01, 0.05, very small number. And it starts off as a very large number, 0.7, something like this. So these are the 3 main types of hyperparameter that you can tune in a decision tree. समझ में आ रहा? Now there are other things also. For example, if you look at this particular example, now if you look at this example, so I said there are 100 records In the first split, female 45, male 55. Then in the female, the second split, I get 30 and 15. Okay. Now I can also tune a parameter that says, when you do a split like this, I want in the result certain number of records, a minimum set of records. There should be at least 10, or there should be at least 5. If it is less than 5, ignore that subset. Okay. Now, for example, here, let's say that instead of 30 and 15, the values were 40 and 5. Okay. Now, the condition that I have set here is I need at least 10. So what will happen? This particular path will be ignored. समझ में आ रहा है? So what I'm setting here is, in a split, the minimum number of samples that I want should be how much? It can be any positive number. You can give 5, 2, 10, whatever, depending upon your size of the data. Okay, so these are parameters that you can tune, and this is called as hyperparameter tuning. So how do you decide which parameter is the best? So the next one is called minimum samples for a subset. So all these things can be done by using a technique in Python known as grid search. Grid search cross-validation technique. So how does it work? Now let us say that I have 20 features. Okay, so number of features equals 20. Number of, let's say you want to control the height. So the height will be, let's say, you want to control from 2 to 5. The complexity parameter is, I want to give this number as 0.01 to 0.05. And minimum samples, I want to give from 3 to 6. So it features 29, it has to be from 5 to 10. So how many values are there for each of them? So here there are 5 values. Here there are 4 values. Here there are 5 values. Here there are 4 values. So how many times this loop will run? 5 into 4, 20. 20 into 5, 100. Into 4, 400. So 400 times this loop will run for every combination. Kaise? Features are kitna? From 5 to 10. So when feature equals 5, the height of the tree is 2. Complexity parameter equals 0.01 and minimum samples equals 3. This is the first combination. Then height is 5. This is 2. This is 0.01. This is 4. Then this is 5. And then this is 6. So this loop is over. So for every combination, when you run a loop, for which combination of features, height, complexity parameter, and minimum samples, you are getting the highest accuracy. Okay, this is done by this grid search cross-validation method. Clear? So we'll do this in the hands-on. So you can specify any values, number of features you want to give this 5 or 4. If you have a very slow machine, not much of RAM, then you can go with a smaller size of data or smaller set of parameters. Online, any questions? Kamlesh?
No, sir. All clear.
Okay. Yes. I have sent you the data set for today. Who's the other person who used to sit there? Keshav. Where is he? Any questions?
Sir, can you explain the controlling the height again?
Controlling the height. See, let's say that I have 10 features. Okay. So let us say my data is split on X5 first. So this is my first split. Then I'm splitting it on X3. Then I split. Then the next split will be based on, let's say, X1. It is split. Then it is split on, let's say, X7. Then it is split on, let's say, X9. Then it is split on X10. Then it is split on, let's say, X2. Okay. So the 10 features, I am not restricting it on the height. It will split on all the features. So kya hoga? Look at the size of the tree. So I want to control this height or the depth. You can call this as a depth also. So don't go and split it on all features. Let the features be 10, but restrict the height or restrict the depth. So if I restrict my depth to, let's say, 3, so where will it stop? This is 1, the first split. This is the second split. This will be the third split. This will not get executed. So I'm restricting the split to a height of 3, which is.
But if we restrict, will we get it given from that?
That is why it is called tuning.
That was
So we have to cross check, right? If we restrict for 3, what is.
That is why we do the grid search. We do not know which point will give us the best. So the hyperparameter, we say, restrict the height, start from 3, go till 6. Or start from 3, go till 10. In this range, which is the best? In combination with others. So that is why the parameter tuning takes time. Because it has to look for every combination. So that if I have 4 parameters, there will be 4 for loops internally for every combination. So the more numbers you give, more time it will take. plus cross validation. So if you are giving a threefold cross validation, it will take that into 3.
Sir, if we have a larger data set and like what is the alternate algorithm which we can implement? Like we have multiple features, more than 20, 50 features. What is the alternative of this?
See, we cannot say just by looking at the data which algorithm to use. We can only say that I can use this. Okay, because the data that you get is raw data. Okay, now I have not done feature selection. अभी मान लो 30 features है, but are all 30 features significant features? That is what you have to analyze. There could be 10 features which are totally useless features. Okay. So let's assume that out of 30 you have taken away 10, so you are left with 20. So out of those 20 are all 20 good features. So let's say out of the 20 you have analyzed and you have seen 2 features are not significant. So again, you are reducing the dimension by 2. So now you have 18. So according to you, 18 good features. Now with the 18 features, I can, if it is a classification problem, I can start, if it is a binary classification, I can always start with logistic. Because that is the base. So first build your logistic regression model, see how the model is behaving with these features. Okay? So a complete implementation of logistic. पूरा उसको squeeze करके निकालना है in terms of how the model is behaving with all 18 features, with the parameter tuning, with the feature selection. Okay, then go to the next model. Let's assume a decision tree, because decision tree is a classification model, a classification algorithm. So first take all the 18 features and see how the behavior is. Then implement the hyperparameter tuning by restricting the height, restricting the CP, restricting the features, all those things. Then you have other algorithm, random forest, KNN, support vectors, all these. So you have to do it one at a time. It's not that always this algorithm will work for these kind of features. We cannot generalize that. Right. Clear?
Sir, you remember we had a discussion last time, like if we have, for example, if we are building a linear regression model, I must be blank, and how to predict the values for y based on your independent variables.
Why? Right.
Were you able to get that kind of data?
I was not able to get it, but I have one data which had some blank values. I think you also have it in your house data.
Yes, like, but we were replacing blanks with.
No. That is not the way to do it. I think in the house data set, there were some blank Ys. So you take those blank values and use them as unseen data and predict them. Because you cannot use a mean value or a median to represent. That is wrong. Ys, if you have a blank Y, you take that as future data to predict. Always impute the features, not Y. Okay? ये वाला समझ में आ गया? Yes. The height, the depth. Okay. Okay, now we'll come to the next part. How does decision tree split? I told you that it splits on the features, but how does the feature get selected that I want to split on this feature first, second, third, etc. So split criteria is done using two mathematical formula. One is called as entropy. And the other is called information gain. Okay. So it's kind of, you don't have to really worry about the mathematical formula and all. No one is going to be, it's not that important. So in short, what it means is when your data is split. Okay, so let's say that I have a gender column and it is splitting into two parts. How much information I get from the individual splits and how much information I get from the overall gender column. Okay, how much information I'm getting from the individual splits. So if this is 100 and my y variable is what? Let's say it is churn. Okay. Now gender and churn. So let's say positive churns are 73 and negative, sorry. Positive churns are 27 and negative churns are 73. So that adds up to 100. Okay. So in the data set, when the gender is counted with the churns, I get the ratio as 27 and 73. So this information, along with what is the individual information that I get from the split. So male is how much and female is how much. Combine these two, you get something called as entropy, you get something called as information gain or IG. So I get an information gain for each of the features. So X1, X2, X3, X4, X5 till Xn. So I get a list of numbers. Now, based on these numbers, the first split will happen based on the highest information which feature is giving you the highest gain. And that is going to be the first column on which the data will be split. Once that is done, the remaining ones, again, it will go through entropy information gain and it will repeat. Do you want to see the mathematical implementation? I mean, not in depth, but just the formula. It is not really required, but if you're interested, I'll show you. See, this is the formula. The hell is the no, yeah. Okay, there you go. Okay, so this is the formula minus P. Minus P means what is the probability of the positive class? So minus P plus. Okay, minus P plus means what is the probability of the positive class? Now, why there is a minus sign? Because when we are taking a log, and when the number is very small, I will get a negative value. So to make it all positive, there's a minus sign. So minus, so if you ignore the minus sign, probability of the positive classes multiplied by log of the probability of the positive classes base 2. Okay, this is important, base 2. Then probability of the negative class multiplied by log of the base 2 of the negative classes. So when you add these two, you get the entropy. Sorry, entropy for this S. S means the feature. So if it is gender, I told you, isn't it? For male, what is the probability? Female, what is the probability? So what is the entropy? So what is the information gain? So gain is the entropy that you have found minus what is the error. Okay, entropy minus error. So this is the error term. So error term for the overall feature. So for the gender, how many are positive class, negative class? You do a summation of that. So when you subtract these two, you get the overall gain.
And how error is calculated?
I'll tell you, that is this formula. I'll explain this later. So S of A is count of attribute value A. That is how many values are there for that particular. So male how many, female how many, divided by S, total count. So 100 if the total record count is 100. So S will be 100. Gender male, how much? Gender female, how much? Multiplied by E of SA, which is entropy for that particular attribute. I'll just give an example, you can correlate it.
Sir, I think the screen share stopped.
Screen?
Meeting.
Right. Now, visible? So I have just taken a small data set. I just made this data set. Okay. So here I have 15 days of data. So there are 3 features and 1 Y variable. Company performance. What is the exchange rate for that day? What is the gold price for the day? And then the action. Whether you want to sell stocks or buy stocks based on these features. So as you can see, they are all non-numeric. Or you can say non-linear. Okay. So this is my data set. Now, if I have a new data, 16th record, where company performance is some value out of these 3, exchange rate is one of these 2 values, gold price is one of these 3 values, predict action. So this is my Y variable, 10 purchases and 5 sales. So 10 purchases, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 sales, 1, 2, 3, 4, 5. So for simplicity's sake, I have taken purchase to be the positive class, sales to be the negative class. Now, which attribute to split on? So what are the 3 attributes? Gold price, then company performance and exchange rate. Okay. So when the company performance, the values are high, low, and medium. If you look at this data set here, high, medium, and low. So those are the individual values for company performance. So when the company performance is high, how many positive classes, how many negative classes? So when this is high, how many positives, how many negatives? Just counting, that's all.
5 negative.
Okay. So when it is high, 3 purchases, 2 sales. If it is low, 3 purchases, no sales. If it is medium, 4 purchases, 3 sales. So this total comes to whatever number, so that will remain constant. When it is low, sale is 0. What is 0? Pure sale. That means I cannot split further. Now, exchange rate, same thing. If it is decreasing, how many purchases? If it is increasing, how many purchases, how many sales? So all these things will add up to how much? 15, because I have only 15 records. Same thing for gold price. It is either stable or unstable. If it is stable, what is the count? If it is unstable, what is the count? So 10 purchases, 5 sales. So this is the first thing that you have to do. Split the data based on each attribute. Clear? Now find the entropy for each of these attributes. So we have already seen this. Now I'm extending this by adding the total. What is the column total? Total positives 10, total negatives 5. Now apply the formula P multiplied by log of P. So what is the total now for total high kitna hai? 3 plus 2. Total low, total medium, Now, what is the probability of this? Total positives का probability क्या है? This divided by total. So 3 divided by 5, 60%. 3 divided by 0, 3 divided by 3, 1. 4 divided by 7, 28%. Sorry, 50%. So this is the positive probabilities. अब इसका क्या करना है? Log निकालना है. Log base 2. So log base 2 of this company. Now you see there is a minus sign. Now the formula has a minus of this. So ये क्या होगा? Minus will disappear. Now P multiplied by this. So this multiplied by this. And then multiply the result with the minus. So this whole thing becomes plus. Do it for the next one, do it for the next one, then add up all these things. Next, negative class. The P of negative क्या है? This one. So 2 upon 5, 0 upon 3, which is 0, 7 upon 3. Do the same thing. Log of 2, P of negative. Again, you have a minus sign. Multiply this by the minus. So you get the positives. Now, what is the formula? This plus this. So that is the error component for each one of them. Then what is the total error? Now, what is the information gain or the entropy? Entropy for company performance. So S of A 3, medium के लिए 3. This is company performance 5, 3, and 7. So S of A divided by S. S is 15 records. So 5 divided by 15 multiplied by entropy for A, which is 0.971. So because we're calculating for high, medium, and low. So you do this calculation. So 0.971 is coming from this one. 0 from here, 0.985 here. So when you do the entropy for each one, you get the information gain for each. Then there is a sigma. So add up everything. So total gain for company performance is 0.135. Okay. No need to remember this. I'm just telling you a brief of the background ki kya hota hai. Same thing for exchange rate, same formula. So here you see the value is 0.3. Same thing for the gold price. 0.2. Now find out which is the highest value. Gold price, exchange rate, company performance. So which is the highest value? Gold price. So which attribute will the decision tree split first? Gold price. So what are the values for gold price? Increase, decrease.
Gold price is stable and stable.
हाँ, जो भी है, stable, unstable. So once this is done, same thing repeats for the remaining records. Find the next best attribute.
So once we calculate the information gain, we know the first one is gold price, second one is exchanges, and third one is company performance. So then it is mandatory to be calculated.
Because once this is split, now I'm not taking all the features. Now I'm left with features minus 1. So this number is not applicable.
It will again change.
It will change. Because I have to find the best attribute based on the attributes available. Now this is already taken. Okay.
But likewise, if we have 4 or 5 or 6 significant features, for all 5 to 6, we have to do multiple iterations to calculate.
That is why when you have a feature which is non-numeric, it is very easy. You just have to count this positive count, negative count, probability count very fast. But if I have a numeric feature, numeric feature mein, how do you find out what is the split condition? Based on split condition, there is nothing, isn't it? For let's say genre, I have action, adventure, drama. There are only 3 conditions. For creative type, I have only these. But number ka kaise find karoge? Age, for example. Now, which number to split? So it uses a system, algorithm called adjacent median, adjacent mean. First 2 records, what is it? Second and third, third and fourth, fourth and fifth, fifth and sixth, sixth and seventh. So it keeps going till it comes to the optimum value. That's why numeric data takes time. Clear hai this concept of decision tree? Any questions?
To calculate information gain and entropy, based on entropy, we have some inbuilt functions.
You don't have to use them. It is, in fact, that is my second topic, the next topic rather, that how do you select which model to use? Okay, so that will be the last and then we'll break. So there are 2 types of models. So there are 2 types of decision tree models. One is called as entropy model, which is this one. What I explained just now, in entropy and information gain. The second model is called the Gini model. Gini model works exactly the same way. The only difference between these 2 is in the formula. So if you notice, Gini model uses a simple formula where it uses only the probability values of the positives and negatives. So in terms of execution, it is much faster. It does not have to do all those complex calculations. So we will be using both these models, entropy and Gini. And incidentally, this is also one of the hyperparameters that can be tuned. Okay, so in the grid search, I can specify model as Gini and entropy, followed by the other parameters that you saw, height of the tree, features, etc. This is plus, not multiplication. Okay, so that's the theory part. Data set is already shared. Download it and then we'll start the hands-on. The data set is it's a multi-class, and it is, I think, E. coli. I think, no, E. coli. तो इसको download कर लो and we'll take a break 15 minutes, and then hopefully we can finish it.
So this Gini model using they have to implement this formula for each and individual features combined.
So this is a model parameter. So when you specify decision tree classification, I will write which model, entropy or Gini.
So in entropy, we use calculate information for individual features, right?
That it will do it within the function. You don't have to do it yourself. Hello.
American gaya था ले variables. 173 there are 6 there. The normalized learning data, normal that normal. That time can show the data is not being or that is object.
That is a normal is not. Then I'm checking the data is normal or not normal. That time you show the data is your string in object.
See, normal, we are checking for normal, isn't it?
Yes. That time I'm.
So for normal, the data has to be number.
Okay.
है ना? Normal का मतलब क्या है? Distribution normal. तो
Normal
so that should have a distribution which is normal. अब normal के लिए data जो है वो number होना चाहिए.
Okay. ये सब जो डाले हैं अभी इसके जो क्या बोलते हैं कॉलम में ये सब चेंज करने वाले होंगे ऑब्जेक्ट को.
हाँ अभी जो ऑब्जेक्ट है you cannot find the distribution for a categorical data. Categorical data का सिर्फ count होता है.
Okay.
अभी zone class में मान लो नाम के zone class.
मुझे ड्रॉप करने वाले का मिलता है.
Drop you will decide after you do the comparison of that feature against the y-value. Either summary से कर लो या you can
बोल रहा हिटमैप में जो इसका वैल्यू देगा तो कम आ जाएगा 0.0
इसका आएगा नहीं क्योंकि ये कैटेगरी.
Yes.
So your input is a category and it's not input. Your x variable is a category and y variable is a number. तो आप क्या टेस्ट यूज करोगे to find the significance? Statistics में किया होगा ना? When you have a you will use ANOVA. I have this. अच्छा ओके. अभी इसका अगर मान लो यूनिक करोगे ना so you will see some unique values. जो भी है 5 10 जो भी नंबर्स है it will give the distribution. That is count. ये zone class 1 में कितने है कौन से 2 में कितने हैं. So that is the count. अब उसका distribution नहीं है. Distribution से ना numbers का होता है. So your implementation of distribution should be for data types which is not an object. So not an object में क्या क्या आएगा? int64 आएगा, float 64 आएगा. अगर date है तो date भी आएगा तो उसको हटाना है.
मैंने नीचे किया था इस बार में. हाँ मैंने वही किया था. ये डेटा चलेगा क्या?
हाँ यहाँ पे int float किया है ना.
हाँ इससे भी एनालिसिस हो जाएगा ना.
हाँ तो df num पे जो भी इंटीजर डेटा टाइप्स है
ओके
या जो भी फ्लोट डेटा टाइप्स है वो आ जाएंगे.
ओके इस पे जब मैं स्प्लिट करूंगा तो कोई दिक्कत नहीं आएगी इससे.
स्प्लिट एज एन
नन जो चेक कम्युनिटी और डिस्ट्रीब्यूशन में जा रहा है ना.
हाँ तो उसको इस पे करना है df num पे.
ऑब्जेक्ट में
df ऑब्जेक्ट पे नहीं करना है. df ऑब्जेक्ट पे आप नल्स चेक करोगे.
ओके
लेवल्स चेक करोगे, ब्लैंक्स चेक करोगे.
जो हम ऑब्जेक्ट में कुछ नहीं करते.
ऑब्जेक्ट में यू कैन नॉट चेक फॉर डिस्ट्रीब्यूशन.
और फिर उसके बाद में जो अपने न्यूमेरिकल वैल्यू है जो अपने टेस्ट में डालेंगे टेस्ट में आउटपुट क्या था पी वैल्यू और वाई प्रेडिक्टेड और लेकिन ज्वाइन आगे
नहीं वो पी वैल्यू फॉर चेकिंग फॉर सिग्निफिकेंस वो दोनों पे एप्लीकेबल है.
ओके
ठीक है क्योंकि ये भी फीचर है ना.
ओके
तो जो पी वैल्यू है वो पूरे फीचर का देता है irrespective of whether it is category or whether it is. ये स्प्लिट हम क्यों कर रहे हैं? बिकॉज ऑफ फॉर EDA. इसमें डिस्ट्रीब्यूशन चेक करना है, इसमें आउटलायर चेक करना है. इधर आउटलायर आ सकते हैं ना. हियर देयर इज नो आउटलायर. यहाँ पे जो आउटलाइन वो अलग है, that is called class imbalance. एक का 100 है, दूसरे का 2 है, so that is an imbalance.
इसके बाद कोई मुझे अभी क्या है मॉडल बिल्ड करना है, मॉडल बिल्ड के बाद जो अपनी प्रोसेस वही करना है।
हाँ, मॉडल बिल्ड करना है, समरी करना है, लीनियर रिग्रेशन assumptions वैलिडेट करना है।
मैंने किया था ठीक है।
Okay.
सब उसने जो बहुत किया वो स्लॉट में भी उसके बच्चे का मैंने देंगे जो मेरा सभी फुट वायरिंग दे देते इसमें मेरे कोई दिक्कत नहीं आई। उसके बाद में एस्पेक्ट अपना एस्पेक्ट क्या ट्रेन हो उसके बाद ये मेरे आया था, ये मैंने नहीं किया इधर से नहीं लाइब्रेरी उसके बाद वाइजल डिस्ट्रीब्यूट किया और इसमें फीचर्स इम्प्लीमेंट किया। फिर मैंने शब्द को चेक किया और मैंने फिर से और जो अपना बॉक्स जो है सब चेक किया मैंने। उसके बाद मैंने फिर से अपना टेस्ट डिस्ट्रीब्यूट किया तो करके और रैंडम साइज भी लगाई। ओके, उसके बाद ये मॉडल जो प्रोडक्ट से सर ये जो मोन आ जाएगा जो अपना बेस्ट फिट ओके है ना, इसमें मॉडल अपना वो है
नहीं, it is overfitting क्योंकि R square 1 means perfect. तो perfect आ गया, perfect means it is too good. तो too good है तो it is likely to fail on another data.
So ये वैल्यू कितने आते हैं यार पर कैसे
नहीं, ऐसा कुछ काउंट नहीं, वो सब आपके नंबर ऑफ फीचर्स पे डिपेंड करता है।
और p वैल्यू जो आपने लेस देन 0.0 कर चाहिए उसे हेट्रो उसका डेंसिटी मींस वेरिएशन होता है ना जो अपने वेरिएबल है और डिस्ट्रीब्यूट ना हो रहा नॉर्मली नॉट कांस्टेंट वही चेक करते हैं ना। हाँ, ये इसमें ऐसा होता है।
This is hetero hard. So this is definitely this is some kind of a because you have lots of variations
not constant parallel prediction समझ में आया मुझे। काम होता है, काम के बाद मेरी इच्छा नहीं रहती।
ये हो जाएगा, जस्ट थोड़ा टाइम लगेगा, इनिशियल थोड़ा दिक्कत है, उसके बाद ठीक हो जाएगा।
अगर मेरा अभी स्किल हो गया 2 दिन के लिए स्किल किया है मैं पाइथन फिर से कर रहा हूँ।
ओके ओके,
ये बैच सब फॉरवर्ड हो गया 2 दिन
ओके।
Hello, sir. You are mute.
Hello?
Hello.
Yeah, Kamlesh.
Yes, sir. You are mute actually.
Okay, I just realized that I was muted. Okay. Now, whenever you have a data which is grouped like this, the first thing you should do as a practice is shuffle it at random, so that you get a mix of the data. Okay. Otherwise, there are chances that you will get a biased data in the training because of the high percentage. So here everything is grouped. So first shuffle and then do the splitting. Okay. So here you can see all the IMs are grouped, all the IMU, OM, everything is grouped, PPs. So first we will do the shuffling and we'll find out what is the count of each of the classes. Are they evenly distributed or is there a imbalance in the distribution? Okay. So let's go to the code now. So you can use Spider app or you can use the Anaconda, whichever you're comfortable with. So Pandas has PD. So the algorithm is called decision tree classifier. The train test split to split the data. Then from metrics, we have the accuracy score. And classification report. Next, we have the feature selection. So in feature selection, there are two techniques that we use. One is using the model. We can find out the important features. I told you in the morning. The second one, we can use a library called as RFE, recursive feature elimination. And then to plot the decision tree, we can use the matplotlib. You can put your own path. Okay. Now you can just print out the data. Just check if everything is okay. So print E. coli. So we have sequence name MCG, GBH, LIP, etc. You can quickly get the shape and size. So there are 336 rows and 9 columns. So this is usual stuff. Then look at the data types. So you can see that except for the sequence name, everything else, and for the Y variable, other things are all numeric data. Now sequence name is a string. How can you confirm if that is a string or not? Unique. Okay. So if I do the unique, so E. coli dot sequence underscore name dot unique. So it is returning me the entire list. So that means it is a string. So what should we do to this? Drop. So since sequence name string, drop this feature. So E. coli dot drop columns equals so just verify whether the column has been dropped or not. So you can do E. coli dot columns. So you can see here that sequence name has been dropped and now you have only the remaining columns. So you can store this in a variable called cols because we'll be using this later. Okay, now if you look at the data, I'm looking at the tail. So E. coli dot tail, just do the last 30 records. So you will see here that all these records are PP. So that means data has been sorted or grouped in according to the Y variable. So I want to shuffle the data. What is the function to shuffle data? It is called sample. Now sample takes one parameter, how much fraction of the data you want to sample. So between 0 to 1, it will take one number. So here I want to sample the entire population. Okay, so I give the value 1 and then store the result back into the same variable. So that means it is going to do a sampling of the same population at random. And now if you print the value of E. coli, and let's take the first 30 records. And now you will. Okay, sorry. I forgot to mention the keyword frac. Just mention the keyword frac equals. Otherwise, you will get only one record. And now equal line. And now you will see that the data has been shuffled at random. If you want to shuffle this further, you can keep doing it. So now you can see CP, PP, everything is it's all mixed. So I want to shuffle it further. Yeah, much better. So frac means fraction. How much fraction of data you want to sample? So if I give 1, it means sample the entire population 100%. Next thing is get the distribution of the Y variable. This is important. So get the Y variable class distribution. So E. coli dot, what is the name of the Y variable? It is LSP. So LSP dot, what is a function to get the count of each class? I want to find how many, if you look at these values, IM, CP, I want to find the count of each of them. 100 is how many IMs are there, how many CPs are there. Count of unique count. The function is value underscore counts. So I'm counting the number of records for LSP. So CP, there are 143 out of 339. IM 77. So it is sorting according to the highest in the ascending order. Sorry, in the descending order. So highest is 143, lowest is IM. Can we say we have a class imbalance? There is definitely an imbalance here, isn't it? If you look at the first class CP, there are 143. And if you look at the last two records, last two classes, there are only 2 and 2. So there are chances that I may not get 100% or at least 90% predictions for the last two. What are the other problems that you see that could happen when I have such a small distribution? How?
Bias towards the value, bias towards PP.
That is there. That will be there because the value of CP is more than almost 50%, almost, or maybe 45%. But what about the last two classes, IMS and IML? What problems you see could happen?
Predicted value towards ML and MS will not be that much accurate.
That is one.
Maybe it can eliminate those two features, although they are significant.
That is not a feature. No? IMS is it's a value. That is a value in the class. How? You are right, but how?
But the output will be more biased towards the higher values.
No, that is there. See. So you have IMS and IML. Both are having 2 records each. Now, when you split the data into training and testing, even though the algorithm ensures that this doesn't happen, but what if it happens? Can it happen that training can have 2? Let's take one class, IMS. Can both the records be in IMS in the training?
Yes.
Testing can be 0. So that means IMS won't be predicted. So is this condition valid? If my testing data does not have IMS, can the model still do a prediction?
No, it cannot do for IMS.
For IMS, it won't do, but
For ST,
it can do. That means this is valid. The model is valid, right? What is the other thing that can happen? Train can have 1, test can have 1. So will it get predicted as IMS?
yes.
We can't say. Because anyway, this is a class. Okay, it has a 50% chance. So this model will predict. What is the third combination?
Train 0 and test.
Train can have 0, test can have 2. Now what will happen?
Model will not predict because it is not trained with that data.
Model will not predict, but will it get built?
It will get built.
Okay, so this is wrong. So how do you ensure that the third situation does not occur? So this is the problem that you can have with classes like these, which have very small numbers. 1, 2. Okay, so if it is 1, it can either go to training or testing. If it goes to training, good. If it goes to testing, then you will have a problem. So what will the model say? It will say that, what is this? I don't know. Give an error because I have not out of syllabus. This is nothing but out of syllabus. Okay. So model will say, I do not know what is this class, unrecognizable class. So if you, in case if you get such kind of an errors, it is because of imbalance in this class. So how do you fix this problem? So there are different ways in which you can do. Number one is, let us say that you don't have any data. This is the only data that you have. And you have no way to manufacture data also, even though you can do it, but you don't have that flexibility of manufacturing data. So the first thing that you should do is, don't let this error happen. So even before you do the model building part, you will do a check. I split my data into training and testing. Count the number of classes. Does the training data have more classes than testing? That is okay. When the training data and testing data have same classes, that is also okay. But when the training data has less classes compared to test, then there is a problem. You cannot have that situation. So in that case, you throw an error and don't let the model to be built. Okay, so you need to ensure this part. What are the other things that you can do to prevent this kind of an imbalance? Can I combine these two into a single class? If you know that it can be done, you should do. If I take all the IMs and put it into a single class. So if I take IMU plus IMS and IML and put this into a class called IM, which is already there. So IM is already 77. So this will become 77 plus
39.
This is how much?
39.
2 plus 35. So 39 plus 77, 7, 8, 116. So now I have from 1, 2, 3, 4, 5, 6, 7, 8. From 8 classes, I have brought it down to 6 classes. This is another way of doing it, provided you know this is the right approach. Okay, I'm only guessing because names are similar. But the person in the lab will say not, they are separate species, separate whatever term that you use. So they are separate, you cannot combine, then it's a problem. Maybe this is a very rare species or a very dangerous species. So you cannot combine them. But I'm just telling you what are the different ways that you can tackle this problem. Okay. Can you write a quick code? I'll just give you this assignment. Okay, let us first split the data, then you can write. So split the data into train and test. This you know how to do it. Do this. Train X, test X, train Y, test Y equals train underscore test underscore split. So my data size is approximately 340 records. So how much should I set the training size to, or the testing size? 70-30? or should I take it 60-40, or should I make 80-20? See, generally 70-30 is a, it's a ballpark figure, but don't blindly follow 70-30. When you have this kind of an imbalance, it's always better to change the sample size for the testing. So try with 75-25, try with 80-20, and then as a plan B, you can go with 70-30. Okay. So that parameter has to be flexible. So let's try with 75-25. So quickly get the count. So train X equals . $252 rows and 7 columns, and train Y has 252. And for the test, you can print it out. $84 records in the testing data. Now you need to count the training and testing classes, so that the testing classes should not be more than the training. Okay. Now, when I say more than that, it means the unique values only. Okay. So if I convert the training Y into a set, I get only the unique values, because sets are a group of values which are unique. So either you can do unique or I can do the set operation. I'll get the same value. So how many values are there? If I do length of the training Y, there are 7. So there are 7 classes. Now set of test Y. So this is also 7. So 7 and 7. So that means training data and testing data both have the same number of classes. So no issues. So this is अभी हमारे पास एक क्लास है, एक
like 8 columns and test wise showing 6 columns.
That's okay. Train should be greater. I'll explain this. अभी IML में कितना है? There are 2 records, 2 classes. Now when I split into train and test. ठीक है, अब इसके दो रिकॉर्ड्स कैसे स्प्लिट होंगे? व्हाट आर द डिफरेंट वेज? ट्रेन पे 2 आएगा, टेस्ट पे कुछ नहीं है. ट्रेन पे 1 है, टेस्ट पे 1 है. थर्ड कॉम्बिनेशन इज ट्रेन पे कुछ नहीं है, टेस्ट पे 2 है. So when I'm building a model using the first technique where both the classes are in train, मेरा मॉडल प्रिडिक्ट करेगा. ओके, क्योंकि टेस्टिंग पे there is no class called IML, so it won't predict IML as IML. So this is fine. When I have one IML in train, one IML in test, this is also fine because it will try to predict IML as IML. तो क्या क्या possibilities होगा? IML will get predicted as IML or IML will get predicted as some other class. ठीक है? So this is also fine. In the third instance, when training has no IML, but testing has 2 IML records. अब इसको अगर मैं प्रेडिक्ट करना चाहता हूं तो दिस विल गिव एन एरर. नाउ व्हाई इज दिस एन एरर? क्योंकि ट्रेनिंग डेटा में द मॉडल हैज नॉट सीन अ वैल्यू कॉल्ड IML. Okay, so it will throw an error saying that this value that you have is an invalid value, or the model has not seen a value called IML. So just to prevent this error, we are checking this condition whether the count of the training classes and the count of the testing classes अगर same है तो कोई problem नहीं है. Category number 2. अगर ट्रेन ज्यादा है that is also fine, but अगर टेस्ट ज्यादा है then it is a problem. So here in this example, training has 7, testing has 7. That means both are having the same classes. That means no problem. Some of you may get a different count, but ensure that training is more than testing. Clear है ये? Now we will build the decision tree model. So we are going to build 2 sets of models. So set number 1 is without hyperparameter tuning. Remember hyperparameter tuning? How to control the depth, how to control the features, how to control the complexity parameter. Okay, so first we will do without any tuning. Then we will do with the tuning by doing a grid search. What are the 2 different types of models?
Entropy
And Gini. Okay, so we will build 2 models, one for entropy, one for Gini.
The output of both models should be same idea. It will be different.
It can be I don't think it will be same. It can be similar, but it will never give you this because the formula itself is different.
Then it will be.
We'll see.
Okay.
That's why we are building both the models. So if entropy works best for this data, for a different data, Gini can be the best. because the distribution of classes are going to be different. Okay. So let's build. So I'll call this model as M1 and let's call this entropy model. And have I used the short form? I have used the alias name called DTC. So we'll use the short form DTC. So decision tree classifier. Criterion means what is the name of the model. So here I'm going to specify entropy. And then fit the training data to this entropy model.
The entropy name is the system given name or the name will give like.
Entropy is the name of the algorithm, the model name.
So we were naming the model.
No. It is the name given for that. I told you, isn't it? Entropy information gain. So we are using that model. So you can just compile this. And then we will build the Guinea model. So we'll call this model 1 underscore Guinea decision tree classifier. And in the criterion, we'll give the model name as Guinea, which is the keyword. Okay, so now I have built the two models without any hyperparameter tuning. Now, if you want to see what are the list of parameters, you can do help and then do DTC, which is the short form. So these are the list of hyperparameters. Okay, minimum weight, maximum features, random state, leaf nodes, impurity, min impurity, class weight, CCP alpha. So n features, n classes, all these are hyperparameters. So we'll look at a couple of them today. Complexity, CCP is the class complexity parameter, this one. Okay, we'll see this later on because it will require some time for you to understand. Other things we can use. Okay, model built without any errors. Okay, now we will see the decision tree. Okay, how the tree has been built. So we'll take any one model. So plot the decision tree. So the features are the columns of the training data. The number of classes will be the unique classes of the training data. So let's give some sample size. So let's say 20 by 15. Just include this library here for what? So import tree. From sklearn, import tree. This will plot the decision tree. So the plot function takes 3 parameters. First is what is the model? So I give the model as, let's give the entropy model to begin with. The second parameter is what are the feature names? So feature names I have given it. It is the columns of the training data. So here you can give train x dot columns. So these are the columns. Then the third parameter is what are the classes? Class names.
2015. 20.
That is the size of the canvas, the figure size. That is optional. Otherwise, if you do not specify, you will get a tiny figure. So I want a larger canvas. That is the number of pixels, width versus height. So what are the class names? Class names are unique classes of the training data. So I'll give train y dot unique. So these are the unique classes. PP, CP, OM, IM, IMU, OML, IML. You can also give a set. That's the same thing. And if you want to give colors to the boxes, I can use this parameter called filled. Filled equals true. Now you will see the decision tree like this. You just have to do a little bit of formatting because I have just taken some random numbers. So a few things are getting chopped off. So just play with the height and width. Just ensure that you get the values properly. Now, if you try to study this, you will see there is a zoom button somewhere. Will that work here? This is supposed to be the zoom. Excellent. So if you look at this figure, you will see that the data has been split according to the features. So AAC less than 0.05. If it is yes, it will come here. If it is no, it will come here. Okay. Now for this, what is the entropy calculation? And how many records are matching this condition? And how many records are matching the else condition? And then the next split. It is splitting based on CP. Sorry, what is that value? I'm not able to make out. Okay. For which one? I'm just telling you how. Yeah. This is just for your reference that how the tree is getting built. You don't have to write any code for this. So as an analyst, you should know. Let us say that you're doing some market research. You want to do some cost-effective campaign. Okay, so you want to find out which path will give you the least price or the least cost. That analysis you can do using this. So the least split giving you the maximum output. So how do you read that? So that's the objective. Clearly, are you able to see the tree? So this gives you the output in the text form. You can ignore this, not really required. Next is we'll do the prediction. So I'm going to do two types of predictions. One is the entropy prediction. So I'll call this P1, prediction of entropy, which is going to be model 1 entropy.predict using the test data. And then the second one is Gini model prediction. Which is P1 underscore Gini equals model 1 underscore Gini dot predict on the test data. Okay. All done. Online, who's this? Kamlesh? Kamlesh done?
Yes, sir.
Okay, so first we will find out in terms of accuracy, which model has performed better. Okay, so let me see if I have taken accuracy score here. It is there. So compare the accuracy of the two models. Print accuracy score of entropy model equals format. So we have a function called accuracy score that takes two values, actual data and predicted data. So actual data is which one? Actual data कौन सा है? Actual classes. Predicted कौन सा है? Entropy का predictions कौन सा है?
The
P1 underscore ENT, right? Those are the predicted classes. Actual classes कौन सा है?
the M1 underscore.
That is a model. Actual classes is the test Y, isn't it? Train Y, test Y. तो test Y तो comparison के लिए रहेगा. So test Y is the actual Y, which is the predicted Y for entropy P1 underscore ENT. And then what is the accuracy for the Gini model? So accuracy score, what is the actual data? Test Y. Because test Y will not change. What is the predicted for Gini? P1 underscore Gini. Now run both these lines. So accuracy score of Gini entropy is how much? 75%. Gini model is 73.8. So based on the accuracy, we have these results. But is this the only way to find the goodness of it? No, we have to see the class-wise predictions. वो कैसे आएगा? How will you get the class-wise accuracies? Classification report. So this is to get the class-wise predictions. So we will first do the classification report for CR is classification report. So CR for entropy model. So we'll write print classification underscore report. So classification report takes two parameters, actual predictions, actual data and predicted data. So actual data is test Y and predicted data for entropy is P1 underscore ENT. Okay. And do the same thing for the Gini model. So just write CR for Guinea model, and here it is going to be P1 underscore Guinea. Okay, now let's execute the CR for entropy. Now here you can see that it is giving some warning messages. Okay, now this can happen when the model does not have any classes to predict. So if you see the error message, you will see it is giving an error. It is giving a warning called zero division error. So you know that we cannot divide a number by zero. So if we want to suppress this message, there is a parameter called zero division. So in the classification report, we have a parameter called zero division. So if I set it to 0, it is going to take care of the problem of divide by 0. Okay, so if I now run these two lines, so now I'll get a clean classification report. So now why that error was happening? Because of this 0, 0. So internally, it is going to add +1 just to suppress that message. Okay. So I'll just clear this and I'll put the zero division here also, because this can also give me a similar warning. So equals 0. And now let me compare the two models. There you go. So CR for Guinea, CR for entropy. Now tell me which is a better model.
Second one.
Now there are two measures here called macro average and weighted average. Okay, so don't worry about that for now. I'll explain that later. What is that? Because that involves some calculations. What I'll do is just remind me next class. I'll show it in a Python code, how that works. So right now, just focus on two things: accuracy for both the models, and how do you find which is a better model. So let us do the comparison. 75% accuracy in entropy, 74% accuracy in Guinea. Okay, not much of a difference. Now let us go class-wise. CP, what is the recall? 91%. What is the meaning of recall?
Yeah.
Look at the precision, 89. Uska matlab kya hai? 89% of the records have been predicted as CP. In that, what is the relevant CP? That is 91. And the remaining 9% is incorrectly predicted as these. So CP as CP kitna hai? 91% in entropy. Guinea में कितना है? 88. So which is higher? Entropy. Next model, next class, IM. 70% relevant predictions for IM. Guinea में कितना है? 65. So in the first two classes, entropy is better. Third and fourth में both are same. 0, 0. No, third and fourth, no, third mein. This is 0, this is 0. So nothing much to compare. 9. Third mein IML hai. Guinea mein there is no IML. Okay, IMS dekho 0, 0. So both are same. Next, IMU 60%. IM 60%. So nothing much. Next, OM 25%. 25%. OML entropy mein 0. OML mein 100%. There is only one record and it has done a proper prediction. PP kitna hai? 90 and 90. So with our initial model, without any hyperparameter tuning, I can see that both the models there is not much significant difference in the predictions. Very small changes in the overall accuracy, very minor changes in the class-wise predictions. So as of now, it is 1-1. Now we will do the hyperparameter tuning to find out if there is any significant difference in the predictions. Samajh mein aa raha hai? So do you recollect what are the different types of parameter tuning that we can do in decision tree? We can control the depth of the tree or the height of the tree. We can control the number of features. We can control how many minimum samples we want in our subset. Okay, we can also control the complexity parameter. Okay, these are some of the typical hyperparameter that you can tune in a decision tree. There are others also, but we'll focus on these 4. These 3 for now. Complexity parameter we'll do later. Now, how many minimum samples that you need? I can take 3, 4, 5, 6, 7. How many? So you define them in a list. How many features that you want to have in your data? Define them in a list. What is the depth to which you want to split? Define them in a list. And then put all these things into a hyperparameter tuning technique called as grid search. Okay, so let's do this. So for that we have a library. So from
In my case, that entropy and entropy is showing 75% practically, we should get 80%.
That's okay because we have different data. We have done random selection. We have not implemented random state parameter. So we will get different things. If we use random state as 5, let's say, so all of us will get the same result. We have to see how different values, different data, how does it behave. So from model selection, sklearn model selection, we have a library called Grid Search CV. there are two libraries. One is called grid search. CV is cross validation. Okay. And then there is another function called as random CV. So random CV is generally used when you have a lot of features. That's a 30-40 features. For small data like this, we will use the grid search. So first we will create a class called decision tree classifier, which is an instance of decision tree classifier. This is going to be the first parameter for the grid search. किसके लिए grid search करना है? हाँ, किसके लिए? Okay. So this indicates. So DTCLF is an instance of decision tree classifier. Now, list of parameters to tune. So I'm going to define a variable called parameters. And then specify the exact name of the hyperparameter. Now, if you look at I showed you the help. Okay, so these are the name of the hyperparameters. These are the name of the hyperparameters: max features, n features, classes, CCP alpha, class weight. These are the names of the hyperparameters. So this is what I have to give in my dictionary. What are the list of values it can take. So the first parameter I'm going to give is the criterion. And then in a list, you have to specify what are the values. So what are the two values for criterion? Criterion means the model name. अभी हमने किया था ना, Gini and entropy. Entropy and Gini.
Sir, ये tuning के parameter same.
ये जो string है criterion, this has to be the name of the actual parameter of the that is going to be used in the function. ये मैं अपने खुद से नहीं दे रहा. So that is why I told you ये जो help जो है decision tree classifier का, this function takes which parameter? I have to specify that name. Abhi, if you look at this one, max features, दिख रहा है ऊपर, minimum weight fraction leaf. Those are the names of the parameters that the decision tree classifier function takes. So this is what I have to supply in my grid search. That is why we are passing the class as DTCLF. Because grid search is a common thing, but it is applicable to specific algorithms. So how does grid search identify where to apply this? That is done based on this instance called decision tree. Now max depth, how much depth I want in my tree. So have I taken NumPy here? NumPy nahi hai na? So just include NumPy. So depth I want to take, let's say, from 2 to let's say 5. So I'll give the function as np.arange. NumPy में किया है ना, arange. It will generate values 2, 3, 4, 5. Okay, you can just check this out. So I want to control the depth from 2, 3, 4, 5. Okay. Then to make a decision, how many minimum samples I require in the leaf?
3.
Up to you. How much I need? Okay. So you can specify that range also. So let us say I want to start from 3 and the maximum I want is, since I have only 300 records, so let me restrict to 9, for example. So I'll have 3, 4, 5, 6, 7, 8, 9. And how many features I want to take. Now, if I take the maximum features to be 3, and if I give a depth of 6, what will happen?
It will go till 3 only.
It will go only till 3, right? So when you're giving these parameters, just check whether they are matching or not. So here I can give the same number as the max depth. So this is my dictionary of parameters for hyperparameter tuning using grid search. Criteria, entropy, Gini. Ensure that these parameter names are exactly the same. Okay, because these will be substituted in the decision tree classifier algorithm. Otherwise, you will get an error. So now perform the search. So I'll call this as grid grid1 grid equals. So where do you want to apply this grid search? On the decision tree classifier. So I have already created the instance here. So create instance of the decision tree classifier. So apply the grid search on the decision tree classifier. What are my list of parameters? That is the params. So it is called parameter grid. So param underscore params grid, param grid equals parameters. Now, because I have a classifier, so my scoring mechanism is going to be what? What is the scoring mechanism in classification? Accuracy. In cross-validation, you have only two scoring mechanisms. One is RMSE, one is accuracy. RMSE is for regression. For classification, it is accuracy. Okay, remember these two. So scoring mechanism is accuracy. Now, so how many loops will be executed? Entropy criteria, there are two values. Max depth 2, 3, 4, 5. So that is 5. So 2 into 5, 10. 10 into maximum leaves, that is 990. Into 5, 450. Now, do you think this will be done as a single process? No. So Python supports multitask. Okay. So there is a parameter called n_jobs. So n_jobs means don't restrict to only 5 parallel processing. Take as many processes as possible to finish this activity. So if I give -1, it is going to take as many processes from the system to finish this task. And the last parameter is, what is the fold? Remember k-fold cross-validation? So here, instead of k, we call the parameter name as CB. So we can give any value here. So if I give 5, 10, so let's give 5. So this is going to perform a 5-fold cross-validation on the decision tree classifier using these parameters. And I want to fit this on which data? On the training data. So now run this function. Okay, so now this is run. So you will find some warning here. It says the least populated class in Y has 2 members. So I have given n splits as 5. So it does not have so many split. Okay, so that thing you can fine tune later on. And now find out the best parameters. So from the grid 1, there is a function called as best_params_. So for my data, it is giving the parameter as criterion equals Gini, max depth equals 3, max features equals 5, minimum samples equals 9. So if I use this combination as my hyperparameters in my decision tree model, I should get a good result. Okay, let's try this out. आपका what are the values?
Guinea 445.
Guinea 445.
Maybe 459.
459. Okay, so that's very similar to what I have got. क्या हुआ? अरे you should tell me क्या है? Don't sit silent. हाँ? क्या है?
The keyword last week.
Parameter. P-A-R-A-M. P-A-R-A-M. Yes. Okay, what about you? What are the values? Okay, अब क्या हुआ? When simple examples. Search. Now do that. Grid का नाम क्या है? So grid one dot best underscore parameters used. Now you can also find using the grid search, what is the accuracy that you are getting? So grid one dot best underscore score. So look at the accuracy now, 87. Okay, you probably will have a different result. So this is the best estimator. So now use, so build model 2, or we can say model 2 with hyperparameters. So model 1 was without hyperparameters. Not set 1, model 1. So without hyperparameter tuning, now I'm going to build model 2 with the hyperparameter tuning. So no longer Gini model, no longer entropy model. So I'm simply going to use model number 2. So what is the criterion? So use the best parameters. Use the best estimator. क्या है? अरे best parameter. Okay, criterion is Gini. So आपका जो value है, you can use that. Gini. क्यों? Then what is the next one? Max depth. So you don't have to write it. यहाँ से copy कर लो उसको सीधा and put it here. And now build model 2 equals 3 equals 5 equals 9. So with the hyperparameter tuning, I have my second model. Now do the predictions. So P2 equals M2 dot predict on the same data test X. So as usual, accuracy score will be the first one. The second one will be confusion matrix. And the third one is going to be classification report. So accuracy score. So print accuracy score for model P2 for model M2 equals dot format accuracy score. What is the actual Y? Test Y. What is the predicted for model M2? It is P2. So here we can see that the result is 67.8. With tuned. Now why it is 67.8? The result that you got was on the training data. And we are predicting it on the testing data. So there could be differences. So don't blindly take the values that you are getting. Okay. That is why we should always check for every value, check the confusion matrix, check the accuracy, and then make your decision. So confusion matrix PD dot cross tab actual data is test Y, predicted data is P2, and then use the margins equals true. So now you can see CP is getting predicted as CP how many? Out of 34, 29. IM out of 23, 19. IMS is 0, IMU out of 10, there are 3, so 30%. OM, 1 out of 4. OML, there is nothing. PP, it is 5 out of 10. Okay, so now you can plot the confusion, the classification report. So print. Test 5. P2. And now you can see CP, IM, and now compare this with our previous results and then find out which is giving you a best results. Do the comparison. So keep working on this model and find out which is the best results. Kamlesh, any questions, any doubts?
No, sir.
Okay, this is clear. Okay, there is only one thing left. That is the feature selection. Now I told you that there are two ways to do a feature selection. And I also told one more thing, remember, when the value is repeating 85% or more, that is called singularity. So we have to do that check also. Okay, so let's do that. Ideally, we should have done it earlier, but that's okay. So what were the two columns?
CHG and
CHG and
LIP.
LIP. Okay. So here you can write check for singularities on the columns CHG and LIP. So we have to do it on the entire data set. Okay. So the data set is E. coli dot chg dot value counts. So can you tell me whether it is exhibiting singularity or not? क्या रैली?
भारत जोड़ो रैली भारत जोड़ो
अच्छा, अच्छा था जोकर is coming. Okay, anyway. So is this singularity? What is the total record size? Length of E. coli कितना है? 336. Out of which 335 are having the same value. So that means CHG has no predictive power because of the bias. Okay. Now check for the other one, which is LIP. E. coli dot LIP dot value counts. Similar है ना? 326 out of 336. That is almost 90%, or maybe more than that. So these two columns can be removed from my data. So two features you can remove. So I can do my feature selection like this. So this is one of the techniques of identifying bad features. Okay. So before we delete, let us find out what is the importance of these two features. So I told you that in decision tree, every model that you build will give you a feature score, which is called feature importance. Now, what are the models that we have built so far? We have built three models: M1 underscore ENT, M1 underscore Guinea, and M2. Three models. Okay, so we can take any one model. And if I do DIR of M2, there is this function called feature underscore importance underscore. Okay, you just have to run this. So important features of the model. So I'll do M2 dot important underscore features underscore. Sorry, not feature importance. Feature underscore importances. So here you can see that it is going to return a list of values. Now, how do I know for which feature am I getting these values? So these are based on the order of the columns. Okay. So instead of writing it like this, I can do df underscore features equals pd dot data frame. You can write feature and then trainx dot columns. And then importance, or you can write score, whatever you want to call this, importance. And just copy this. paste it here. Okay, now print df underscore features. Now you can see that feature and its importance. Now I can sort it according to the feature importance. So you can just do df underscore features equals df underscore features dot sort underscore values. So sorted by importance. And sort it in the descending order. So give the flag as ascending equals false. And now you can see the important features are MCG, ALM1, ALM2, and look at LIP and CHG. 0 and 0. So what you have analyzed as singularities, you have verified that using the feature selection. Sorry, feature importance. So along with that, there are other features like AAC and LGVH, which is also giving a 0 score. So that means they are also not important.
Sir, for ASC and GV, I have got some value.
But I'm getting here 0, but I should not blindly look at these because I know they are actual values. But for the other two, I know for sure they are insignificant features. Clear? So now what is going to be your next step? Removing those two features, rebuild the model and repeat this process. Okay, so that finishes decision tree. Drop the features, drop columns. Was it too fast? Okay. Yo, fast था? मैं इससे slow जाऊंगा ना? It will take 2 days for such a simple topic.
Tomorrow बस वो दो calculations.
हाँ.
Yeah.
वो जो CCP है, that is called cost complexity parameter. तो उसका theory I'll explain it. उसका coding थोड़ा complex. That's why I didn't do it today. अगर वो नहीं है तो भी that is fine. वो यहाँ पे है. You can give here. See this one, where you are building the model. So there is a parameter called CCP underscore alpha. So if I give the value as 0.01, this is the cost complexity parameter. So abhi to maine aise I have given a random value, but you need to determine what is that value. So which is that minimum value after which I can remove my excess tree. So that is done using a graph. So it will plot the accuracy, and you have to find out, determine which point you have the maximum accuracy, and then it is decreasing. So wo point ko pinpoint karna hai, then put that value. So it's a bit tricky.
This is used for optimization.
I'm happy we could complete it today. So I was planning a 5-6 hour session को बहुत ज़्यादा हो गया. अगला algorithm is very simple. Random forest. 2 hours finish.
Random forest classification.
Yes. It works on the CART model, classification and regression in CART. So you can use it for both classification and regression, just like.
Can we take one more example for decision tree where all the values will be categorical?
I think you have that in your assignment. If I remember it right, it is called mushroom type prediction.
Then we have to replace those values with terms or directly can be. It is not like linear or anything.
I want to show you one example of decision tree with regression. Decision tree can also be used for regression models, regression problem sets, and why you should not use decision tree for regression. Next week, if we have time, we'll do that. Then we'll try to complete both these decision tree regression and see. That is for very soon.
For decision tree, we have hard disease prediction.
Heart disease, not question. So you can use this data set. Binary, you know, the 3 classes. Please check whether it is binary class or unity class. Classes. No. Target. Binary. Okay, Kamlesh, any questions?
No, sir.
Fine, and so you use the LMS to practice the question given on decision tree, and we can discuss that if you want next week. Okay, so we'll meet on Saturday.
Okay, sir.
Okay, bye bye.
Thank you, sir.
Yeah.
मला अजून पण लिहिणार झाली शिकवून काय नाही आपण काढून करतो